Breaking right now out of southern Japan, Sakurajima, the most active volcano in the entire country, just produced its tallest ash column of the year, 4.4 kilometers straight up. And it's not a one-off. This is the fourth major escalation this volcano has produced since April, and this time the warnings have spread into a second prefecture. 680,000 people live within a few kilometers of this crater. We're going to walk through this exactly the way it unfolded, month by month, event by event, so you understand exactly how we got to this point and what's actually happening on the ground right now. Real dates, real numbers, no filler. If you're anywhere near this volcano or have visited it yourself, tell me in the comments. And subscribe now because this story is still developing. Let's start the timeline. April 2026. This is where the year's escalating pattern actually begins. Just past midday, the Minamidake crater produces the volcano's first genuinely major eruption of the year, sending an ash plume roughly 3.4 kilometers into the sky. Debris scatters up to a kilometer from the crater. Flights out of Kagoshima Airport get disrupted. Here's the detail that matters most from this specific event, though. Scientists at the Sakurajima Volcano Research Center, who track the mountain continuously using GPS sensors and tilt meters monitoring ground deformation from rising magma, oranges, confirm afterward that this eruption actually helped ease most of the crustal deformation that had been building inside the volcano in the weeks before it. Translation: pressure had been quietly accumulating underground, and April's eruption released a meaningful chunk of it. That's not just a dramatic ash column, that's the volcano's internal pressure gauge visibly dropping in real time. It's worth noting this specific finding because it flips the intuitive assumption most people bring to a headline about a volcanic eruption. In this instance, a genuinely large explosive event was, in the scientific sense, a moment of the volcano becoming temporarily safer rather than more dangerous. May 8th, 2026. Just under a month later, Sakurajima produces its largest eruption in 6 months. A Volcanian-style explosion, sudden, violent, driven by trapped gas pressure, rupturing a plug of hardened lava near the surface. The ash column reaches somewhere between 3.4 and 4.4 kilometers, depending on the exact measurement window. Here's what makes this one different from April, though. This eruption generates the volcano's first pyroclastic flow in more than 5 years. Pyroclastic flows, fast-moving currents of superheated gas and volcanic material, are one of the single most dangerous hazards any volcano can produce. And the fact that Sakurajima hadn't generated one in half a decade means this wasn't routine background activity. This was a genuine escalation. The Tokyo Volcanic Ash Advisory Center issues warnings about ballistic rock impacts and pyroclastic flow danger within roughly 2 kilometers of the crater. And Japan's meteorological agency keeps close watch as additional explosive events continue through the following week. For context on just how significant the 5-year gap actually is, Sakurajima produces thousands of smaller eruptions in any given 5-year stretch, meaning the absence of even one pyroclastic flow across that entire period reflects a genuinely unusual, comparatively quiet stretch for the volcano's more hazardous eruption category, right up until May 8th, broke that streak. June 7th, 2026. This is the entry in the timeline that turns volcanic activity into something residents could physically feel under their feet and see coating their cars. At 6:52 in the morning, a powerful eruption begins and continues for roughly an hour, sending ash and smoke 300 meters above the Minamidake crater. On its own, roar. That's actually a smaller plume than either April's or May's event. What makes June different is the weather. Strong easterly winds, amplified by an approaching low-pressure system, carry the ash plume directly westward over Kagoshima City at the exact moment local rainfall is moving through. Ash and rain combine into what residents start calling gray rain, a thick, sticky sludge coating roads, streetcars, bicycles, and vehicles across the entire city. The cleanup gets bad enough that gas stations see genuinely long lines specifically for car washes. It's almost a darkly funny detail, but it's a real illustration of how a volcanic hazard can collide with completely unrelated weather to create an entirely new category of disruption nobody planned for. It's a useful reminder, too, that ashfall risk isn't purely a function of eruption size. The timing and direction of local wind and weather systems can turn even a comparatively modest plume into the most disruptive event of an entire season for the people actually living underneath it. Let's also put Sakurajima in context against volcanoes elsewhere in the world, because the sheer frequency of activity here is genuinely unusual, even by the standards of other highly active volcanoes. Compare Sakurajima's roughly 15,000 eruptions since 1955 to a volcano like Guatemala's Fuego, itself considered one of the most consistently active volcanoes in Central America, which produces significant eruptive episodes on a scale of weeks to months, rather than the near-daily rhythm Sakurajima maintains. Or compare it to Hawaii's Kilauea, famous for sustained effusive activity, but which goes through extended dormant periods lasting months or years between major eruptive episodes. Sakurajima's pattern, thousands of discrete explosive events spread across nearly 7 decades with barely a pause, places it in a genuinely small category of volcanoes worldwide that maintain this level of sustained, near-continuous activity while sitting directly beside a major population center. That combination, extreme frequency plus proximity to hundreds of thousands of residents, is precisely why Japan has invested so heavily in the specific monitoring infrastructure built around this one mountain. That brings us to right now, early August 2026, and this is the breaking part of this story. According to CNN's reporting, Sakurajima produces eruptions and explosions, sending ash and debris more than 2,000 meters into the sky on 3 separate occasions, with one of those reaching a full 3,000 meters. Days later, a further explosive eruption hits at 12:57 in the morning local time, and this one sends ash to 4.4 kilometers, the tallest single plume the volcano has produced all year, beating out even May's pyroclastic flow event. According to Calibur Daise's reporting, no pyroclastic flows are reported during this specific eruption, and Japan's meteorological agency holds the alert level steady at 3, choosing not to escalate despite the record plume height. Here's what did change, though. Ashfall advisories go out not just for Kagoshima Prefecture, where the volcano actually sits, but extend into neighboring Miyazaki Prefecture as well, reflecting exactly how far this particular ash cloud was expected to travel. Separate reporting from JFeed confirms additional secondary bursts, scattering heavy ash across surrounding communities beyond the immediate blast zone, and dozens of flights get canceled at Kagoshima Airport, as ash accumulation and reduced visibility make normal operations unsafe. As of the most recent reporting, there are 0 confirmed casualties and 0 reports of structural damage from this entire sequence, a genuinely reassuring detail given the scale of what just got recorded. Now let's answer the obvious question. Why didn't officials raise the alert level given that this is the tallest plume of the entire year? Japan's volcanic alert system runs on 5 levels, and it's built around observed activity plus modeled hazard zones, not simply plume height in isolation. Level 3, the level Sakurajima has sat at continuously since July 27, 2022, translates to "do not approach the volcano," restricting access within roughly 2 kilometers of the craters based on how far ballistic rocks and pyroclastic material could realistically travel under current conditions. Moving up to level 4 or 5 requires evidence of eruptions capable of directly threatening populated areas beyond that established zone, and despite the record height this month, that specific threshold hasn't been crossed. In plain terms, Sakurajima is running noticeably hotter in 2026 than in a typical recent year, without yet showing the underlying warning signs, changes in seismicity patterns, new dramatic ground deformation, direct threats to populated zones that would justify moving the needle further. It's a genuinely different standard than the one most casual observers instinctively apply, judging danger by how tall or dramatic an ash column looks on video. And it's precisely the reason volcanologists keep emphasizing that the instrument data, not the footage, is what actually determines the official response. It's worth pausing on how scientists actually distinguish between different types of eruptions in this timeline, because not every explosive event carries the same hazard profile, even when the ash columns look similarly dramatic on camera. May's Volcanic eruption involved a relatively short, violent explosion caused by trapped gas pressure suddenly rupturing a plug of cooled, hardened lava blocking the conduit near the surface, sudden and forceful but comparatively brief. June's gray rain event reflected a different underlying process entirely. A longer, more continuous venting of gas and ash without the same explosive, plug-rupturing mechanism driving May's activity. And this month's sequence, multiple distinct explosive events spread across several days rather than one single sustained episode, suggests the volcano moving through several discrete pressure release cycles in rapid succession. Each of these patterns carries a slightly different hazard profile, which is exactly why the monitoring data behind the scenes matters more than the raw plume height numbers that dominate news headlines and thumbnail images. Let's zoom out and talk about why this specific mountain erupts as constantly as it does, because that context explains everything about how officials are handling this. Sakurajima sits on the southern rim of the Aira caldera, an enormous volcanic depression roughly 17 miles across that itself formed around 22,000 years ago in an eruption that dwarfs anything the mountain has produced since. That caldera sits on top of an active magma chamber, and Sakurajima essentially functions as its primary pressure valve, a role it's played consistently since the current eruptive period began in 1955. Rather than pressure building silently toward one catastrophic release the way it did for over a century before 1914, the mountain now vents continuously through thousands of smaller eruptions every year. Since 1955, that's added up to more than 15,000 recorded eruptions from the Minamidake and Showa craters, working out to well over one eruption every other day on average, across nearly 7 decades. That frequency is exactly why the Sakurajima Volcano Research Center tracks crustal deformation so closely, watching for the specific scenario where magma accumulates faster than the volcano's normal eruptive rhythm can safely release it, which is precisely the pattern that had been building before April's eruption eased it. It's also worth understanding what makes Sakurajima's ash specifically hazardous to aviation, since flight disruption has been a recurring theme across nearly every entry in this year's timeline. Volcanic ash is not the same as ordinary smoke or dust. It's composed of tiny, extremely hard fragments of pulverized rock and glass, capable of sandblasting aircraft windshields, clogging sensitive instrumentation, and most dangerously, melting inside a jet engine's combustion chamber before re-solidifying on cooler internal components, a failure mode that has caused genuine engine shutdowns on commercial aircraft in past volcanic events elsewhere in the world. That's precisely why airlines operating out of Kagoshima Airport treat any significant ash advisory as an automatic trigger for flight delays or cancellations rather than waiting to assess conditions visually, and why the Tokyo Volcanic Ash Advisory Center's rapid notification system, often issuing formal advisories within minutes of an eruption beginning, exists specifically to give airlines and air traffic controllers across the entire region enough lead time to reroute flights safely away from an active ash plume before it becomes a genuine in-flight hazard. Here's why Japan takes this monitoring so seriously in the first place. It comes directly from history. Sakurajima technically used to be its own separate island, sitting in Kagoshima Bay just across the water from the city. That changed in 1914, and what remains the most powerful volcanic eruption Japan experienced during the entire 20th century, the Taisho eruption. It followed more than a century of near total dormancy, and it arrived only after a series of large, unmistakable earthquakes gave residents enough warning that nearly everyone had evacuated before the mountain fully let go. The eruption started violently explosive, generating eruption columns and pyroclastic flows before major earthquakes over the following 2 days pushed it into a longer, effusive phase that produced a massive lava flow, the same lava flow that physically connected the island to the Osumi Peninsula, permanently turning it into the peninsula residents live on today. Ashfall reached all the way to Honshu, hundreds of kilometers north. That eruption happened with essentially no dedicated monitoring infrastructure in place. Residents relied entirely on felt earthquakes and visible surface changes to know when to run. That near catastrophe is exactly why the Sakurajima Volcano Observatory was established in 1960, and it's operated continuously ever since. Continuous GPS and tiltmeter data tracking, ground deformation, gives researchers a genuine real-time picture of how much magma is accumulating and how fast pressure is building toward another release, essentially letting scientists watch the mountain breathe in a way that was completely impossible in 1914. The Tokyo Volcanic Ash Advisory Center now issues formal advisories within minutes of any significant eruption. In April's case, less than an hour after the eruption itself even started, giving airlines, ferry operators, and local authorities real, actionable information instead of having to react purely after the fact. Let's talk about what daily life actually looks like for the roughly 680,000 people living in Kagoshima City, because this is genuinely one of the more remarkable civic adaptations anywhere in the world. Specialized ash-sweeping trucks run along major streets essentially every morning during active periods, treated as routine municipal work rather than emergency response. Train lines generally keep running through most eruption events unless visibility drops severely or ash triggers safety sensors on the tracks. The Sakurajima Ferry, connecting the city directly to the volcano's own peninsula, runs 24 hours a day and keeps operating through most Level 3 activity. Regular evacuation drills are simply part of how the city functions. Residents get practical daily guidance rather than alarmist warnings during typical eruptions. Wear a mask during heavy ashfall, avoid unnecessary outdoor exposure, check the official JMA advisories before making plans. Decades of lived experience have turned what would be a standing national emergency almost anywhere else in the world into something the local population manages as part of ordinary life. Local schools even incorporate volcanic safety directly into standard emergency preparedness curriculum, alongside earthquake and tsunami drills that are already a fixture of Japanese education nationwide, meaning most Kagoshima children grow up with volcanic ashfall response as second nature by the time they reach adulthood. There's a real economic cost buried in all of this too, and it's worth naming directly. Kagoshima's tourism economy depends heavily on visitors drawn specifically by Sakurajima, adventure travelers, geologists, photographers, everyday tourists willing to accept a well-understood level of risk to witness genuine volcanic activity up close. But June's gray rain event and this month's expanded ashfall warnings and flight cancellations both show exactly how fast that manageable risk can spike into real short-term disruption. Hotels dealing with cancellations, restaurants losing foot traffic, ferry operators occasionally suspending service, local shops watching customers disappear during the worst stretches. all part of the real and recurring cost of living beside the most active volcano on the planet. Even in years where, as has been the case throughout this entire 2026 sequence so far, nobody actually gets hurt. It's worth adding a practical safety rundown here because it applies just as much to anyone traveling through Kagoshima right now as it does to long-term residents. The Tokyo Volcanic Ash Advisory Center issues formal advisories within minutes of any significant eruption, and those advisories are publicly available through the Japan Meteorological Agency's website alongside high-definition live camera feeds monitoring the crater continuously. Anyone in the region during active ashfall is advised to stay indoors when possible, wear a mask if venturing outside is unavoidable, and avoid all non-essential travel until conditions clear. Guidance, local news outlets, and hotel staff communicate routinely during active periods. Flight status should be checked directly with airlines rather than assumed, since cancellations during heavy ashfall events, like the ones confirmed this month at Kagoshima Airport, can happen with limited advance notice once ash accumulation on the runway or in the flight path crosses safety thresholds. For anyone specifically near the coastline or lower-lying areas during a gray rain-type event similar to June's, avoiding contact with the resulting ash and rain sludge and washing any exposed skin or clothing promptly is standard local guidance, since the mixture can behave more like a mild abrasive slurry than ordinary rainfall runoff. So here's where things stand as of this update. Sakurajima has now produced 4 distinct escalating eruption events across 2026, April's pressure-releasing eruption, May's 5-year pyroclastic flow milestone, June's gray rain disruption, and this month's record 4.4-kilometer plume with expanded ashfall warnings covering 2 prefectures and confirmed flight cancellations at Kagoshima Airport. The alert level remains steady at 3. No casualties, no structural damage reported from any of this year's activity. And based on everything the monitoring data is showing, officials aren't seeing the specific signals, new seismic patterns, direct threats to populated zones beyond the restricted area that would justify pushing the alert level higher. What this timeline does show clearly is a volcano running hotter in 2026 than in a typical recent year, moving through repeated build-release cycles that scientists can now track with real precision, even without being able to say exactly when or how big the next release will be. It's worth being direct about what would actually need to change for this situation to escalate into genuine emergency territory, because that clarity matters more than vague reassurance. Volcanologists monitoring Sakurajima would be watching specifically for a sustained shift in the pattern of ground deformation, showing magma accumulating faster than the volcano's regular eruptive activity can release it. A change in the location or depth of seismic activity suggesting movement toward a different, potentially larger magma pathway, or direct evidence of pyroclastic flows or ballistic debris reaching beyond the currently established 2-kilometer restricted zone. None of those specific signals have been reported as part of this month's sequence. That's precisely the distinction between the most dramatic eruption sequence of the year and evidence of an approaching large-scale disaster. And it's exactly why officials have kept the public response calibrated to match what the actual monitoring instruments are showing, rather than to match how dramatic the ash column footage looks on camera. Anyone tempted to draw a straight line from this month's record plume height to something on the scale of 1914 should keep that distinction in mind. The mechanisms that would signal a comparable escalation simply aren't present in the current data, however impressive the footage itself looks. We'll keep tracking Sakurajima as this story develops, along with every new advisory from the Japan Meteorological Agency and the Tokyo Volcanic Ash Advisory Center. Given the pace this year has already shown, 4 distinct escalation events in barely 4 months, it would be reasonable to expect another significant development before this year is out, and we'll be covering it the moment it happens. If this timeline gave you the clearest picture yet of what's actually happening, subscribe so you catch the next update the moment it drops. And tell me in the comments if you've ever witnessed a volcano up close. Stay safe, and we'll be right back with more the second anything changes.